Hi, I'm Mickey Cheatham, and I'd like to talk to you about a career opportunity brought about through the Programmer Retraining curriculum. After selection for retraining, the first step is Programming Fundamentals. Programming Fundamentals is a 13-week, full-time kickoff to the programming curriculum. This is where it all begins. It's the start of a 12 to 24-month-long effort on the student's part. Programming Fundamentals is offered at most IBM sites. The goals of the course are, first, to teach the basic programming concepts. Equally important is to begin to foster good programming habits. The course also covers all the elementary skills required by any programming professional in any job in the industry. Most importantly, Programming Fundamentals provides the foundation for all the university level and environmental classes. The course is modeled after the computer science curriculum recommendations set forth by the Association for Computing Machinery. Most university curriculums follow these same guidelines. In the broadest sense, Programming Fundamentals includes material on problem solving, an important part of the programmer job and one that's vitally important to the student's future. Structured design, with emphasis on documentation, requirements, and top-down methods. Structured programming, stressing readability and ease of maintenance, along with the structured constructs of sequence, selection, and iteration. Data structures concentrates on the selection of appropriate data types, including simple and complex types, as well as abstract data structures. In addition to this basic information, the course covers material on other subjects which are an important part of the IBM job. These include the software development process, documentation, software testing, inspections, and team programming. In 13 weeks of concentrated study, each student will come to understand all of these principles and be ready to move on. Meet Robert Thompson, one of our Programming Fundamentals instructors. He'll fill you in on more of the course details.
The Programming Fundamentals class is half lecture and half lab. Obviously, it's not all theory. Each student gets maximum hands-on training with the current concepts on their computer. There's a quiz each week to make sure that all the objectives have been accomplished. Here's the schedule for the first week. We start, naturally enough, with an introduction to computing. Next, we examine computer architecture, language levels, compilers, and operating systems. By midweek, we're into binary and hexadecimal arithmetic. And we finish the week's material with the basic machine cycle, addressing modes, and the quiz. Week 2 moves on into the areas of problem solving and structured programming. Both flowcharts and pseudocode are used for program design. Program construction and the Pascal language is introduced, as well as the importance of documentation and program style. By this time, too, the lab assignments are gaining momentum. The first real program, called Hello, is compiled, and students are working on another Pascal project called Math 1. The students complete daily reading assignments and work on self-evaluation questions to focus on areas that require additional study. Review questions and classroom discussion help prepare the student for the weekly quiz. As you can see, we cover a lot of material in a short space of time, but tutoring is available at any stage. Week 3 starts with data input, proceeds through selection logic and the if statement to requirements and specifications, and an introduction to test case design. In the lab, a large top-down design project is underway, in addition to a Pascal project called Math 2. During week 4, we cover several different kinds of loops and introduce text files and arrays. As always, coding style and debugging techniques are emphasized. In the lab, the students continue with the top-down design project and start the File I/O project. We deal with subprograms and procedures during most of week 5 and finish up with test plans and code inspections and walkthroughs. Lab sessions continue with array sorting and credit card 2. For week 6, the topics include functions, the case statement, sets, and more on loops. This week starts the first team programming project. This represents the halfway point through the course. I'll be back after a short break.
While Robert catches his breath, let's talk for a moment about how this Programming Fundamentals course got started. The course objectives were defined by an IBM committee, and the course developed by various university faculty members. 2 pilot classes were taught in 1985. Over the years, the course has been revised through feedback from students and instructors, and Programming Fundamentals is used today at 14 IBM sites in the United States and Europe. One question that is frequently asked is, why is Pascal used as a language basis for this course? The answer is simple. Pascal is a tool for learning and demonstrating programming concepts. Pascal was designed specifically for programming instruction, so it's the language of education. IBM uses many different programming languages, so the language required on the job is best taught in the environmental part of the curriculum. Pascal gives us a common language within the company on which to build this curriculum and to teach basic programming concepts. Plus, Pascal gives us a common point with new computer science hires, with university faculty members, and it's consistent with modern design languages. So Pascal makes the most sense from an educational point of view. Now, let's return to Robert Thompson for the rest of the Programming Fundamentals schedule.
Week 7 starts with a change in emphasis from control structures to data structures. It begins with introduction to user-defined data types, their declarations, and internal representations. This is followed by an in-depth coverage of one-dimensional arrays and array processing. The lab sessions start the most ambitious lab project to date, Merge 1. We continue with multi-dimensional arrays into week 8 and introduce records. Various combinations of records, arrays, and files are studied. This week also introduces the abstract data types, stacks and queues. Merge 1 continues in the lab, and we start a new project which creates an address book file. Week 9 introduces dynamic variables and pointers. Various linked lists and operations on these structures are studied. In the lab, a project is started which involves performing maintenance on an existing program. By this point in the course, the students have learned most of the basic concepts involved in programming. They are beginning to apply these concepts in many rich and various ways. Week 10 topics include more on pointer data structures, such as trees, plus new material on analysis of algorithms. The lab sessions focus on the maintenance project, and we start the last regular lab project called Linked List. Our 11th week wraps up the topic of software testing and introduces other subjects that will be covered in depth in the follow-on courses. The students are now ready for the final lab project. Some classes start this project immediately, but at some IBM sites, the students take a break from Programming Fundamentals to learn another additional programming environment, such as VM, or to learn an additional language, such as C or PL1. These students then complete the final phase of Programming Fundamentals using this new programming language. Weeks 12 and 13 do not include lecture or quizzes. Rather, the students work in teams on a full-time project. This project covers the gamut of everything we've done to date and includes management, role-playing, team projects, specification generation, test plans, design, implementation, integration, and testing. The students gain experience in inspections, team leading, and working from documents created by other students. At the end of the 13th week, the students have completed the Programming Fundamentals course and are prepared to take the university level and environmental courses. They're on their way.
While that last big project summarizes the contents of the entire Programming Fundamentals course in a simulated real-world environment, the students are not considered qualified programmers just yet. Each one has the solid foundation necessary for continued study toward technical parity with computer science graduates. Their work in programming can start, but their studies have just begun.